Hey, welcome back. We are studying Chapter 4, Proportional Relationships, and we are doing in Lesson 4, Similar Figures and Proportions, and this is the guided practice. So the first thing they're asking us to do in this guided practice is just to determine which side corresponds with the other side. So if we look at 1, it says AB corresponds to, so here's side length AB, and it wants to know what side does it correspond to over here. Well, whenever I'm like doing this, I think it's easier just to figure out, okay, let's look at the biggest side first. So the biggest side is right here, right? The biggest side on this triangle is here, and the biggest side on this triangle is here. So we know that those correspond with each other. And then after you find the biggest side, sometimes it's easiest to find the smallest side. And to me, since there's no numbers, we're just kind of doing it by what we see. The smallest side looks like BC here, and the smallest side over here looks like YZ, which means the one in the middle must be right here, and AB must correspond to XY right there. So now we can kind of fill in the questions. It says AB corresponds to, so this is the middle side, AB corresponds to XY. Number 2, BC corresponds to, this is the smallest side, it corresponds to the smallest side over here, which would be YZ. And then finally, number 3, AC, the biggest side corresponds to the biggest side over here, XZ. All right? So there we go. That's how you do that problem. I want to go ahead and do problem number 4 with you, and then I'm going to have you do 5, 6, and 7 on your own. So the first thing we want to do is see if they look like they have a similar shape. And yes, they have a similar shape, but it just looks like the size is different. So we know that we're in the realm of starting to see if these are similar triangles. So what the directions say is it says identify the corresponding sides, then use the ratios to determine whether the triangles are similar. Okay, so let's go ahead and start with the biggest side. So the biggest side would be, let's see here. If I'm looking at, I'm going to just do the big triangle on top. So that would be here, DF. Over the biggest side on the little triangle, if we're looking at the numbers, would be 5, which is AC. So now that we have that, we just fill in the numbers. So DF is 10. So it's going to be 10 over AC is 5. 10 over 5. And we know that 5 goes into both of those numbers, so we want to reduce this. 5 goes into 10 2 times, and 5 goes into 5 1 time. So our ratio is 2 over 1. Okay, perfect. Let's go ahead and figure out the middle side now. So the middle side is going to be the number in the middle, which we start with the big triangle because we did the big triangle on top here, so we have to make sure we do the big triangle on top here. So it's going to be EF over the middle side here, which would be BC, which is equal to, we got to plug in the numbers, so EF is 8 over BC is 4. All right. And then we just simplify this. So what number goes into both 8 and 4? Well, I know that 4 goes into both 8 and 4. 4 goes into 8 2 times. 4 goes into 4 1 time. So our ratio is 2 over 1, which is the same. So that is great. So far we are on track for these being corresponding triangles. Now we just have to do the shortest side. So we're going to do the shortest side. And we do the big triangle on top. So the shortest side for the big triangle is DE over the shortest side for the small triangle, which is right here, AB. Then we plug in the numbers. So DE is 6. 6 goes on top, and AB is 3. So we have 6 over 3, and then we want to reduce that and see if there's a common factor, and yes, there is. 3 goes into both 6 and 3. 3 goes into 6 2 times. 3 goes into 3 1 time. So our ratio is 1. And it's the same as all of them, so that means that they are proportional and that the triangles are similar. All right. You then use the ratios to determine whether, yep, they are similar. The triangles are similar. So there we go. Now it is your turn, ladies and gentlemen, to go ahead and do problems 5, 6, and 7. And I want you to go ahead and show your work and try to see if the if the triangles are similar. Where's my friend? Oh, here's my friend, the pause dragon, reminding you to pause, work out these problems, and then when you get done, press play, and we will see how you did. All right, see you in a bit. See you in a bit. All right, we're back. Let's go ahead and get started with problem number 5. So the first thing we're going to do is let's go ahead and do the biggest side. So the biggest side, let's start with the big triangle and have the big triangle on top. You don't always have to do the big triangle on top, but I just want to stay consistent. So the big triangle is going to be NP, that's the biggest side here, NP, over K, the biggest side on the smaller triangle is KL, right there. So over KL. Now we're just going to fill in the numbers. So NP is 8, so it's going to be 8 over 7. And I don't think we can reduce, so we just leave it as 8/7. So that's it. Okay. We have the biggest side. Let's go ahead and find the middle side. Excuse me. Sorry about that. The middle side. Okay, that was a nice little sneeze. So what I'm seeing is that these are the same, so it's not like we have a middle side or a small side because they're the same number. But we have the biggest side on the bottom, so I'm just going to say that this is my middle side, the one on the left, which is going to correspond with this other one on the left. So yeah, that's what I'm going to go with. So I'm going to call my middle side MN. It's going to be the big triangle over the little triangle, and it's going to correspond with JK. I'm going to go ahead and fill in the numbers. So MN is 6 and JK is 5. And I can't really reduce this ratio. This is in simplest form. And if I look at this and I compare these two ratios, they are not the same. So really at this point, I don't have to go any further. I know that the triangles, I'm going to say the triangles are not similar. So that's all I need to do for that one. Once you find that those ratios are not the same, you automatically know that they're not similar. So you should have had the triangles are not similar for that one. If you did, great job. Okay, let's go on to problem 6. Okay, we are going to go ahead and start with the biggest side again. Okay, let's see how you did. So with the biggest triangle, so I got 18, 9, 15. So 18 is going to be the biggest side, which is ST. ST is the biggest side over, the biggest side over here, 3, 5, 6 would be HJ. Then I'm going to go ahead and fill in the numbers. So ST is 18 over HJ is 6. I'm going to reduce these. So is there a common factor between 18 and 6? The answer is yes. 6 goes into both. 6 goes into 18 3 times. 6 goes into 6 1 time. So the ratio is 3 over 1. Okay, so that's the biggest side. Let's go ahead and try the side in the middle. The middle side. Okay, so when I'm looking at these numbers, I see that 15 is the number in the middle. So RT is going to be, and we're going to keep the big triangle on top of you got to keep it consistent. So RT, the big triangle's on top of the fraction, and the small triangle is going to be on the bottom. So where's the middle side? Would be right here. That's the middle number. 5 is in between 3 and 6. So that is GJ. GJ. That's kind of difficult to say if you say it 5 times fast. GJ. Can you say it fast? It's GJ. It's kind of hard. Anyways, okay, moving on. We're going to fill in the numbers. RT is 15 over GJ is 5. Okay, and I'm looking for a common factor between 15 and 5. I would say yes, they have a common factor of 5. 5 goes into 15 3 times. 5 goes into 5 1 time. So our ratio is 3 over 1, which is awesome because that is the same. So we're going to keep going. They have the same ratio, so they could be similar, but we have to look at the shortest side. Okay, so let's look at the shortest side. All right, where are you at, shortest side? Okay, remember we got to do the big triangle on top. So this is the shortest side, RS, over the shortest side over here is GH. Then we fill in the numbers. RS is 9 over GH is 3. And so we're looking for a common factor between 9 and 3. And 3 goes into both. 3 goes into 9 3 times. 3 goes into 3 1 time. So our ratio is 3 over 1. And it's the same. Woohoo! That means that the triangles are similar. Okay? So if you got that one right, woohoo! Good job. Okay, let's go on to problem 7. Okay? Let's see if these triangles are similar. Now this is, looks like they're all the same thing, so it's going to be a little difficult to say what side goes with what side, but since they're all the same measure, these are all 5, 5, 5, and these are all 4, 4, 4, they're all the same, so I don't think it really matters. So we're just going to pick one. We'll just call it, I can't even say biggest because that's not biggest. We're just going to say one side. One side would be, what would one side be? One side would be, and they look like they are the same shape. They're just different sizes. This is all 5 and this is all 4s. So one side is going to be, let's just start here with UV. Okay, so I'm going to say this is the biggest triangle. So the biggest triangle is going to be on top. So it's going to be UV over, and I'm going to say this corresponds with XZ. And at this point, because there is no biggest, small, they're all literally the same, and these are all the same, it doesn't really matter which one you put. because I think it's all going to work out, but we're just going to put UV with XZ. If you have something different, that's okay at this point because this is one that's kind of a little different. So anyways, we're going to plug in the numbers. UV is 5 over XZ is 4. So the ratio is 5 over 4. Okay, so then we're going to do the next side. I'm just going to call this the next side. Because I can't really call it the middle one because they're all the same. So I'm just going to call the next side, this one right here, UW. So UW, the big triangle, over the smaller triangle, and I'm going to say that's going to correspond with this one right here, XY. And then I'm going to fill in the numbers. So UW is 5 over XY is 4. So the ratio is 5 over the 4. And that's great. It's the same. So far they can be similar. And then, I don't know, I'm just going to call this another side. Because I can't call it the smallest side because it's the same as the other ones. So this is just another side. Got to do the biggest triangle on top, which is going to be VW. So it's going to be VW over YZ. And we're going to fill in the numbers. VW is 5. And YZ is 4. So there we have it, 5 over 4. And that is the same. So the triangles are similar. So if you got that one right and you showed all your work, great job. Now your paper should look like mine. So you need to show your work like this, okay? Okay, let's flip the page and talk about problems 8 and 9. Okay, so 8 and 9 are dealing with quadrilaterals. So let's go ahead and start with 8 and 9. Let's start with 8, working on it together. So the first thing we want to look at is, do these have the same shape? And for them to have the same shape, they have to have the same angle measures. Now, if you look at this little box right here, that little box means that it's 90 degrees. So this is 90 degrees, that's 90 degrees, that's 90 degrees, and that's 90 degrees. And then if you look here, this is 90, 90, 90, 90. So the corresponding angles have the same angle measures, so you know it is the same shape. We're just going to look at the size and see if the sizes are the same. So let's go ahead and start with the biggest side that corresponds. So let's start with it. So the biggest side here would be, I'm going to have the biggest, would be a rectangle. So I'm going to have this QT on top, the biggest rectangle on top of the ratio, and that corresponds with AD right there. Now the cool thing about a rectangle is that these sides correspond, but it's really the same thing as those two, but we'll talk about that in a little bit. So QT, let's go ahead and fill in the numbers. So QT equals 8. And AD equals 4. So we're going to go ahead and simplify this. 8 and 4, do they have a common factor? And the answer is yes. 4 goes into both. 4 goes into 8 2 times, and 4 goes into 4 1 time. So our ratio is 2 over 1. Okay, now when I'm looking at this, it has another biggest side. And so the other biggest side that it has, I'm going to kind of do this in 2 parts, is this one over here. This big triangle also has 8. Okay, so that's 8 there. And so I'm going to call that RS, and I'm just going to write it below it, RS, because that is also the biggest side, over the BC here. Okay, over BC. And then I'm going to fill in the numbers. This is 8 over 4. And it's the same thing. 4 goes into 8 2 times, 4 goes into 4 1 time, so the ratio is the same. So it's the same here. Okay. So then we're going to do the shorter side. So the shorter side, let's look at this side on the top. And we are just going to have QR right there. So this is going to be on top of the fraction, QR over AB. That's the shorter side. Then we fill in the numbers. QR is 6 over AB is 2. So we go ahead and we look if there's a common factor between 6 and 2, and there is. 2 goes into both. 2 goes into 6 3 times. 2 goes into 2 1 time. So 2 goes into 6. 2 goes into 6 3 times. 2 goes into 1 1 time. So the ratio is 3 over 1, and that is not the same as 2 over 1. So what that means is that these, the figure is not similar. So this is not the same. So the figure is not similar. So once you find one ratio that is not the same, you don't need to go any further. You have already determined that the figures are not similar. So boom, there you go. That's number 8. Let's go ahead and look at number 9. Okay, so this is the last one in this section. Now we want to make sure they're the same shape. So what it says is the corresponding angles have to have the same measure. So what is this? This is another quadrilateral. 1, 2, 3, 4. Yeah, 4-sided figure. 1, 2, 3, 4. So I'm going to look at the angle measures. So this angle measure here is 131 and 131. So those are the same. I'm going to move over here. We have 80 and 80. So that's the same. Here we have 59 and 59. So that's the same. And lastly, we have 90 and 90. So that means that the shapes are similar. They have, the angle measures, the corresponding angle measures are the same. Okay, so they have the same shape. Now we have to determine if they have, if their size is proportional. And so we need to do that by looking at the corresponding sides. But the first thing you want to do is look at the angle measures, because if the corresponding angle, like if this is 131 and this was 130, you could just say, no, these are not similar right off the bat, and you don't even need to do any calculations. So if you have the angle measures, you just want to double check first to make sure that all the corresponding angles are the same. And we did, 131, 131, 80, 80, 59, 59, 90, 90. So there you go. So let's go ahead and start with the sides. I'm going to go ahead and start with the biggest side. Okay, the biggest side would be what? What is the biggest side of the biggest quadrilateral? So let's put this one on top. Okay, we got 9, 6, 4.5, 10.5. Okay, so that's the biggest side right here, which we would call that WX. So we're going to put the biggest quadrilateral on top. So WX, and the biggest side here, 6, 4, 3, 7, would be right here. GH. Okay. And then we're just going to fill in the numbers. So WX is 10.5 over 7. Okay. Now, that's not a super easy calculation. At first glance, you would think that it's not, what's the word? That it's not the same. I'm going to say what the easiest thing to do in this example, I think would just be to divide it. I think we just need to divide it. So I'm going to go down to my scratch paper, and we're just going to go 10.5 divided by 7 and see what that is. Okay? So I'm going to go down here. I'm going to go 10.5 and divide it by 7. 7 doesn't go into 1. 7 goes into 10 one time. 1 times 7 is 7. 10 take away 7 is 3. I got to put that decimal there. Then I drop the 5. And 7 goes into 35 5 times. So that means this ends up being 1.5. And changing it to a decimal isn't always my favorite thing. We could convert that 10.5 to a fraction, and then we'd have a complex fraction, but we haven't talked about that. So we're just going to go ahead and divide the decimal and call this 1.5, just for this problem's sake. Okay, so let's move on. We're going to go now to the next biggest one, or so like this, we'll call it the second biggest. The second biggest? Yeah, this is the biggest. This is the second biggest. Okay. So the second biggest, and make sure we put the big quadrilateral on top, would be, what's the second biggest? That would be right here, 9. Yeah, 9. So what side is that? That's called XY. So it's going to be XY over, the second biggest over here, 6, 4, 3 would be HJ. And then we fill in the numbers. We have XY is 9 over HJ is 6. Okay. So we have 9 divided by 6. So we're just going to go ahead and convert that to a decimal. So 9 divided by 6. Does 6 go into 9? Yes, it does. One time. Oh, you couldn't see that. Could you see that? I'm sorry. Do you see how 9 is the next one? 6HJ. Do you see that? XY over HJ, which is 9 over 6. I'm sorry, it was off screen. Okay, so we have 9 over 6. I hope you're with me. So we're just going to go ahead and do the long division and see what decimal that is. So 6 goes into 9 one time. 1 times 6 is 6. 9 take away 6 is 3. There's a remainder, so we need to add a decimal and add a 0. And then drop it down. 6 goes into 30 5 times, so we have the same ratio, 1.5. So that is the same, which is great. Okay, so now let's go ahead and try. Let me make sure I get you back in screen. Okay, the third biggest side. Third biggest side. Okay, third biggest side. Okay, so the third biggest side, which would be this one, would be YZ. Okay, YZ, make sure we're putting this on top of the ratio or the fraction. YZ over the third biggest would be right here, JK. And then we go ahead and fill in the numbers. So that's going to be 6 over 4. And we're just going to convert this to a decimal. So I'm going to go 6 divided by 4. And then do that division. Does 4 go into 6? Yes, it does. It goes in there one time. 1 times 4 is 4. I do the subtraction. So 6 take away 4 is 2. I have a remainder, so I need to add the decimal and add a 0, and then drop it down. 4 goes into 25 times, and so there we have 1.5 again, which is the same, which is great. So far this is similar, but we have to check that shortest side. So I'm going to check the shortest side. The shortest side. Okay. The shortest side and we're going to have the big one on top, would be right here with WZ. Uh-oh. Do you see that? I'm sorry. The shortest side right here is WZ. So this is going to be on top, WZ, over the shortest side here, which is GK. And then we're going to put in the numbers. So the numbers for this one is 4.5. WZ is 4.5. Over the number for GK is 3. And then we're just going to, this is 4.5 over 3. We have to do that division to see what that is. So I'm going to go over here. 4.5 divided by 3. 3 goes into 4 one time. 1 times 3 is 3. 4 minus 3 is 1. And then we put the decimal there. We drop down the 5. 3 goes into 15 5 times, and 5 times 3 is 15. And there is no remainder. So boom, there we have it. This equals 1.5. Ooh, 1.5. So I'm just going to write it again. 1.5. It's having technical difficulties writing, which is the same as all of these, which is great. Which means the figures are similar. Boom. So that's how you show your work for these, for quadrilaterals, and that's how you solve the problem. So if you got that right, yoke it ikimashita, you did a good job, and we will see you next time. Bye-bye.